Okay, these are some problems from 10.3. I'm just going to work off my notes. I think they're pretty legible, just to save a little bit of time here. And this is number 41, and what we want to do is we want to find the slope of the curve at each indicated point. So first of all, we have to find a formula for the slope, and that's going to be dy dx, which is going to be dy d theta over dx d theta. And this is my curve in terms of theta r equals, or as a function of theta, r equals 2 minus 3 sine of theta, and x is r cosine of theta, and y is r sine of theta, so that's how we're going to get these into the xy form, so I can take the dy and the dx of theta. So this is r, so this is r, we know that y equals r sine of theta, so I'll take r times sine of theta, and I'm going to get y, and then I have to take the derivative of this, and we're going to just use our good old product rule. Okay, first times the derivative of the second, so the derivative of sine is cosine, plus the second sine times the derivative of the first. Derivative of 2 is 0, and that's going to be negative 3 cosine of theta. All right. And, I mean, you could leave it in a pretty raw form. I just simplified. And this is stuff you should be able to do anyway, things you should know how to do as far as the simplifying. So first of all, I distributed this. I multiply this out. 2 cosine of theta and negative 3 sine theta cosine of theta. And if I multiply this, I've got negative 3 sine theta cosine of theta. Whenever I see sine theta cosine theta, I'm always thinking two-angle formulas, and I can simplify those. And that's always a little bit easier. So whenever I see that, I can think of simplifying this. All right. So I've got 2 cosine of theta minus, and then negative 3 of these, and negative 3 of these is negative 6 of those, which is the same thing as negative 3 times 2 sine theta cosine theta, and that's my two-angle formula for the sine. So I can rewrite this as 2 cosine theta minus 3 sine of 2 theta, and that's a little bit easier, so that's simplified. And again, you should know those two-angle formulas by now pretty well. Okay, let's go take a look at x now. X equals r cosine of theta. So x equals r, which is 2, oh, I put it over here, sorry. X equals r, which is 2 minus 3 sine of theta times the cosine of theta. There's my r over there. And let's multiply times cosine of theta to get the x. And then I take the derivative. Okay, I don't want to multiply it out first and take the derivative. I just used this because I looked ahead and thought it would be easier just to leave it in this form. So first times the derivative of the second plus the second times the derivative of the first. So the first times the derivative of the second, the derivative of the cosine is negative the sine. I put the negative there, and there's the sine, so there's the negative sign. Plus the second, which is the cosine, times the derivative of the first. The derivative of 2 is 0, negative 3, and the derivative of the sine is the cosine. And I multiply these out. Let's see if there's any simplifying I can do. So I've got negative 2 times the sine of theta, all right? And a negative times a negative is a positive, 3 sine squared of theta, all right? And this is going to be a negative 3 cosine squared of theta. Now, whenever you see the sine squared and the cosine squared, you're always thinking, well, can I make one? Well, that's if they have the same SIGN. These have opposite SIGNs. But then I think there's another two-angle formula. All right? So if I factor out the 3, or even I factor out a negative 3 and reverse them, so if I take out a negative 3, that makes this positive cosine and negative sine squared. Sorry, positive cosine squared minus sine squared. Then I've got the cosine formula. That's the two-angle formula. Cosine of 2 theta. So I simplify it again. So I've got negative sine of theta, negative 3 times the cosine of 2 theta. That's nice how that worked out, isn't it? So now I can put my remember my dy dx way from the top. My dy dx is dy d theta over dx d theta. So my dy dx would be dy d theta, which was up here. This was a simplified form over here. Okay, 2 cosine theta minus 3 sine 2 theta. There's my 2 cosine theta minus 3 sine 2 theta. And my dx d theta is right there. Negative 2 sine theta minus 3 cosine 2 theta. Okay, so there you go. So there's your derivative formula right there. All right, and that's a pretty simplified form. Okay, and then we want to evaluate this at these various points. So here's the arithmetic over here. We just have to substitute in. I tried to show as many steps as I could without going overboard. At 2, 0, this is going to be r theta, so theta is 0. If I put 0 in here, I got, remember the cosine of 0 is 1, so I got 2 minus 0 over 0 minus 3. I think you can do the substitution. All right, and then I drew a little unit circle over here using my 0, 1, 0, 1, 0, 0, 1, negative 1, 0, 1, negative 1, because I'm going to do a lot of these. Because these asked you for pi and pi over 2s and 3 pi over 2s. Looking ahead, so I figured I was going to do a lot of that, so I drew that over to help me. So this is 2 minus 0 over 0 minus 3, so you can check that out. That should work out. Negative 2/3, and at negative 1 pi over 2, I want to evaluate my derivative at theta equal pi over 2, because that's all I have is thetas here. And that ended up being 0 minus 3 times 0 over negative 2, and times negative 3 times negative 1. Well, this is negative 2 plus 3, so this is just 1 in the bottom and 0 in the top, so I got 0 over 1 is just 0. Okay, and then over here at 2 pi, I put pi in, and I got 2 times negative 1 over minus, I'm just substituting in here, 2 negative 1 minus 0 over 0 times negative 3 times 1. And that ended up being negative 2 over negative 3, which is just 2/3. And at 5, 3 pi over 2, again, theta is 3 pi over 2, so I put 3 pi over 2 in these 4 spots. I got 0, negative 3 times 0, negative 2, and negative 3 times negative 1. Well, again, this is going to be 2 plus 3 is 5, so, but this is just 0 on the top, so it's 0 over 5, which is 0. So you can check all that arithmetic, and I think that should be okay. That's number 41. Hope that helps.